this year. Yeah.
All right, everyone, thank you very much for coming to the CHDH seminar today. Before we begin, I would like to acknowledge that we're meeting on the traditional lands of the Wurundjeri people and pay my respects to their elders, past, present, and emerging. This is also pretty exciting for me to pay my respects to Andrew, who I've had the privilege of working with for the past few years. You'll hear all the details about this talk, but I wanted to point out that much of the work that he'll be presenting on really grapples with a lot of, no pun intended, core questions in, what does it mean to have knowledge, represent knowledge, what sort of affects how we learn those things, and does so in using some quite intricate and pretty difficult to design experiments. And Andrew, in his modest way, will probably undersell the intellectual contribution from him that came before we did any experiments and just figuring out how to measure and test what we did. So yeah, it's been a real pleasure having you as a PhD student for the past few years, and I'm expecting great things afterwards, so no pressure. Yeah.
Thanks, Andy. That's setting a really high bar for me. So thank you everyone for coming to this completion seminar. My name is Andrew. My supervisors are Andy Perfors, Meredith McCaig, someone over there, my chair is Charles Kemp. And the title of this talk is Core Vocabulary in Language Representation, Processing, Communication. I'll just double check, can everyone hear and see me on Zoom? Is that working there? Okay, cool. So the year is 1884, and James Murray is a Scottish lexicographer, and he's writing what will eventually become the first edition of the Oxford English Dictionary. And in the introduction, right at the beginning, he writes, "The circle of the English language has a well-defined center, but no discernible circumference." And what he means becomes clear when you think about all the different ways that we use language as humans, both historically and contemporarily, with different audiences for different purposes across different generations. And so all these niche, many and varied uses of language sit on the edge, but as you move back towards the middle, there seems to be something in the language that's constant, something that might be central or fundamental to the language, what you might call a core. So the question is, well, what is this core? What are these core words in language? What are these most important words in a language? And there are various ways to think about this. So for example, what are the words that define the meanings of all of the other words in a language? If you were to learn the language, what are the best words to start out with to learn the rest of the language as effectively as possible? For communication, what are the most important words for communication that allow us to communicate in the simplest possible and most efficient ways? So all of these things point to the idea of core vocabulary. And now, how should we define it? What have previous approaches done? So maybe they're the most frequent words. So many of these word lists that have been published for learners to learn when they start learning the language are often based on a combination of frequency plus expert judgment about which words are most useful for learners to start out with. Maybe they're the words that define the meanings of all other words. So Anna V. Spiska's work on semantic primitives is an attempt to find a core set of lexical items that is sufficient to define the rest of the words in a language. So if you start off with a complex word, and then you define the meaning of that complex word in simpler words, and so on, is there a core set of words at the bottom of that that allows you to define the rest of the words in a language? Similarly, you can look at dictionary definitions in a very similar way. So the words that define the meanings of all other words in terms of dictionary definitions. So maybe that's also a way that we could identify these core words. Maybe we can identify core words based on a set of structural semantic properties that we think core words should have, like core words should be superordinate words, or they should be polysemous, or they should be highly productive and participate in a lot of compounds. So there are also these lists of structural semantic criteria that have been proposed and published to kind of define what are the core words in a language. From a historical linguistics perspective, core vocabulary has also been defined as those words that are resistant to borrowing, so that are less likely to be replaced by words from outside the language. And this kind of makes sense if you think that there's a core set of words in a language that remain in the language and stay within the language over time, diachronically. And then finally, it's also been defined cross-linguistically. For example, in terms of words that follow extremely consistent patterns of use when we look across the world's languages. So these are some of the previous approaches to core vocabulary, but these approaches still don't seem to get at this idea, this intuitive idea of core vocabulary that we started out with in a satisfying way. So for example, we know that rules do not provide a sufficient account of word meaning on their own. And so how valid are those notions of core vocabulary that are based on rules, like the semantic primitives and the dictionary accounts? Is that really how we think people are representing word meaning when they think about word meaning? Similarly, we also know that people readily think in terms of basic level categories rather than superordinate concepts, whereas superordinateness is often proposed to be a key property of core words. So it raises the question of when we propose certain criteria that we think core words should have, where do those criteria come from, and do they really align with how people think about language intuitively? And just more generally, there's kind of a general disconnect. So these approaches haven't made much contact with the rich body of work that we know about from cognitive psychology, cognitive science, about how people know and use language. It just doesn't seem satisfying that the words that hold the most importance to speak is the words that are core to speakers are rooted in historical linguistics or based on a survey across the world's languages or determined by experts. Yes, there are probably links there, but it seems that we should be really looking at what people do with language as a starting point, and look at how people represent and process language themselves. So that is really the key motivation behind this project. And so the aim of this project is to investigate this idea of core vocabulary, but to approach it from a psycholinguistic perspective and look at how people learn and represent and process language. And then to empirically test these measures of core words that we derive empirically using tasks that tap into different aspects of language representation and use. And as we'll see, these core words also provide insights into these capacities of representation, processing, and communication themselves. And so the studies I'm going to present are going to move through these themes. So we're going to start with words and look at lexical representation. And then we're going to move up to sentences, talk about word prediction. And then finally, I'm going to move up to texts and talk about a couple of studies that investigate reading comprehension. So starting off with study one. And the goal for this study was to look at, well, how can we start to define this idea of a core vocabulary in terms of how people know and learn and use language? And so that was the question for this study. And from this perspective, I'm going to come back to word frequency, but now we're going to think about it again from a psycholinguistic perspective, because from a psycholinguistic perspective, word frequency empirically is an extremely important predictor of word process, one of the most important in the literature. And high frequency words are likely to form stronger representations in memory and have stronger lexical access and be able to be activated more easily. So word frequency is an extremely important variable here. But then again, how about this idea that the core words should be those that are somehow more central to the meanings of all other words in a way? How can we look at that from this psycholinguistic perspective? Well, one way to look at the structure and organization of word meanings in semantic representation is using word association networks. And to look at word association networks, and maybe if we look at the central words in semantic networks, the ones that are central in terms of all their connections to all other words, maybe that's also a way that also comprises a kind of representational coreness. So we can use centrality measures in semantic networks like in strength, though there are others to do this, to look at this. One last one I'm going to talk about is the words that are learned earliest in life or age of acquisition. And these may be psychologically core because they're highly entrenched in the mind. They're the first words to enter the mental lexicons for people. And also because of accounts like the preferential attachment principle. So this idea that nodes in a network gain more nodes probabilistically based on the number of connections they already have. So these kind of semantic growth models make the prediction that the oldest nodes in a network kind of become the central hubs of the network. So these psycholinguistic measures that are by no means new, they've been in the literature for a long time. But viewing them from this theoretical perspective of what is core in the human mind, I hope the show provides new insights and different insights into people's language behavior. And so looking at some examples of the core words that each of these measures gives shows that they are quite different from each other and that they reflect different characteristics. They reflect the properties of the measures that they come from. And of course, there are many other measures, many other possibilities that we could use or that we could have explored in this space. We still might. But these three measures have kind of nice theoretical motivations to them, and they're different enough in interesting ways that we can tease them apart experimentally. So we have to start somewhere ultimately. So we're going to start by looking at these three. So the aim was to test these cornice measures, to take these cornice measures and test them on a task that taps into aspects of language representation and processing. So like word meanings, what are the words that make up the meanings of all other words? Lexical access, how easily are words activated in the mental lexicon? And so we used a simple meaning-based word guessing game for this study, where we had people guess target words from sets of hint words, and which was really the simplest possible starting point that we could start to use to evaluate some of these core words empirically. And so the questions we had here were which core words make the most effective hint words? So you can compare this with the semantics primitives approach, the kind of words that define the meanings of all other words. And then which core words are the easiest to guess target words? And so we had a task where we told people that they were guessing computer passwords based on a series of hints that were related in meaning. So a typical trial might look like this. So you start out with one hint word and we let participants make a guess after each time. You can play along if you like. So that's one guess and that might be wrong. So you move on to the next word, the hint that we showed there. Again, we let participants make another guess. And that wasn't right. So you'd see the next hint and this would continue until you guess the right word. And if you guess the right word, or you saw up to 6 hints, then we let that, we gave participants the answer and well done if you got that at home. So for the target words, we kind of factorially manipulated the measures so that we had words that were more core on each of our measures and less core on the other two. So we had kind of words that were more core in terms of in strength, AOA and WF that served as the target words. We also had a set of target words that were equally core across our 3 measures. And that was the equal target condition. The hint conditions were a set of core words that we chose from each of the 3 measures. So we had we took the top 300 core words from each of the measures and we called that the core word lists. And then we selected hints from those pools. So we had a pool of in-strength core words, a pool of AOA core words, and a pool of WF core words. And we selected the hints from each of those conditions for the target words using semantic similarity metrics. So we had a metric that was word association based and a metric that was based on word embeddings, based on word effects. So because semantic representation is part of what we're investigating here, and there are different ways to model semantic representation, we didn't want to necessarily bias one or the other. So that was a reason for using multiple kinds of semantic similarity metrics. So looking at the results, what I'm going to show you is for the accuracy for target words that people guessed in the experiment, which you can see there on the y-axis. We have the different types of target words there along the x-axis, so target condition. And then the colors represents the different types of core words that made up our hint words in this task. And so looking first at just one of the target conditions. So what you can see is that the accuracy across the different types of hints was actually quite similar. And in fact, this is what we found. So we didn't find any differences between our different types of hints. And overall, actually, the accuracy was quite low in this task, which made us think that the core words were not very effective as hints in the first place. But looking at the differences between the target conditions themselves, we found bigger differences there. So what we found is that the in-strength target words were consistently more accurately guessed, then followed by the AOA, so followed by, lastly, the WF target words. So there were bigger differences between the types of target words when we looked at the target words, regardless of what the hints were, regardless of what the hint condition was. So this was interesting, and it kind of this kind of lack of difference between the hint conditions combined with the low accuracy overall for those hints made us kind of ask, well, how effective are those core word hints in the first place? And are they even more effective compared to non-core word hints? So we ran another experiment to look at this. So we had a condition where for each participant, we had a random sample of 300 non-core words that served as the pool of hints, the list of hints. Non-core words, so words that were just not defined as core under any of our three metrics, and 300 is like a comparably sized pool to those core word lists from which we drew the core word hints. And then we had another condition where we just drew hints from all available words, regardless of whether or not they were core or considered core or non-core. And here what we found when we add these conditions to the results, what we saw is that actually the core word hints from experiment one were quite comparable in terms of accuracy to the random non-core vocabulary hints. The full vocabulary hints were much better than both, which kind of makes sense because that's a much larger pool of hints that we can draw from. But what we showed, more importantly, was that the effect of higher accuracy for those in-strength target words remained for the conditions in this experiment. And in fact, the effect was actually even stronger when we used these hint conditions. So what we also found was when we looked at those semantic similarity metrics that we use to select hints for target words, so the semantic similarity between the targets and each of their hints, target words with higher similarity to their hints had higher accuracy, as you would expect, but then that still doesn't explain the differences between our target conditions. So in-strength target words still had high accuracy, even after taking into account the degree of semantic similarity between the hints and the targets. So overall, what did we find from this experiment? We found that the core words were not very effective as hints. They were not more effective than non-core words, which was somewhat surprising. It may kind of run counter to the idea that the core words are supposed to be the ones that make up the meanings of all the other words. But then again, the way that we operationalized word meaning in this task is very different to kind of the way that word meaning is operationalized in like those accounts like semantic primitives accounts and the dictionary accounts, where it's not just a simple word cue word relationship. It's about how those core words build up and define the meanings of all those other words in a much richer way than probably what we did in this experiment. So I won't be revisiting this today, but it does seem that there's more that we can do here in terms of like actually investigating how words composed make up the meanings of other words. What we did find, however, is that these in-strength target words were consistently the best guessed, regardless of what the hint was, and also even after taking into account factors like semantic similarity, among other things like part of speech and concreteness. And that suggests that there's that these kind of words are privileged in semantic memory in some way, that they are more accessible, they might be more prominent within the semantic representation. But these words may also have been favored have an advantage because of the nature of our task, which is quite similar in many ways to a word association task. So we still think this is a useful first pass. It was useful for investigating how people conceptualize words in isolation and their relationships to each other. But what about a task? If we use a task that is much more communicative and contextual in nature. So that brought us to study 2. Where we're looking at word prediction as a task. So word prediction is a task that is much more communicative and about language use and about the way that words are used in context. So word association data really reflects the semantic relationships between individual words whereas measures like frequency reflect distributional information in the linguistic environment. So when it comes to a task like word prediction, maybe you might expect frequency might do well here. It might seem, by the way, that we've moved away from word meaning a bit here. So why are we suddenly talking about word prediction? It's a bit out of left field. How does it follow up from the last study that we ran? But then you have to remember in accounts like the distributional accounts of meaning, those two things are equated, right? So word meaning is how words are used in context. And so that's what we're trying to get at with this word prediction task. So the question here is, are frequency-based call words more useful in a task that is predictive and in a task that is more about distributional information than our last task? And so we used a word prediction task in which people saw a single sentence with a target word missing, and they had one chance to guess this target word. We used the same target words from study 1. So again, those are the in-strength, AOA, and WF target word conditions. We also, for this experiment, we also included the set of target words that were non-core. So again, words that are not defined as core under any of the 3 metrics, to kind of provide a baseline comparison to those core target words to see how well predicted they are compared to those non-core words. We sourced the sentences from the ententer web corpus. We wanted kind of naturalistic and realistic instances of language use instead of making up our own sentences. Now, words are going to be more or less predictable in the context they occur in to different degrees. And so we need a way to quantify this. So we measured predictability, or we calculated predictability of words in context using BERT, which is a language model, a large language model. And the different types of words have very different distributional properties. So what you can see here, what I'm showing you is that the high frequency core words, those WF ones, they tend to be much more highly predictable in the context they occur in, just in the corpus compared to the other types of target words. So their predictability distributions are much higher. And that kind of reflects the natural variation in the corpus. And so we wanted to both allow for and control for this. So we had 2 kind of sets of sentence conditions. So we had a set of corpus match sentences for each target word. So that was 36 sentences that were chosen for each target word to match their empirical predictability distributions that we observed in the corpus as closely as we could. And then we had match predictability sentences, which were 10 sentences that were chosen at the same predictability values for each target, to kind of make predictability the same across all our target words. So we had sentences where we're controlling, yes, the predictability across all target words, and sentences where we're matching the corpus distributions as closely as possible. And so when we look at the results, again, just looking at accuracy, if we look at those corpus matched sentences first, in line with the predictability statistics, the frequency-based core words did have high accuracy on this task. But again, those kind of words have much higher predictability to begin with. And so if we control for that, so when predictability was controlled for both statistically by accounting for it as a factor in the statistical models, and experimentally using those matched predictability sentences, we found that, again, in-strength and AOA target words had higher accuracy for reasons that went beyond their predictability. And it's also interesting to look at what people put when they didn't get the target word. So if they didn't get the target word, what were people responding with instead? And so what we're looking at here is the most common incorrect responses that were given for the corresponding target words. And what we can see is that people really preferred what were essentially simpler or more basic alternatives to the target word that still fit the context in a suitable way. So these were things like a more basic synonym for the target word, or a more general term that kind of captured the same meaning. And this goes back to the motivating idea of core vocabulary, right? That it should capture a kind of simplicity in terms of meaning, and a communicative usefulness in terms of expressing the same idea, but in a simpler way, in a way that is just simpler. And so maybe these are the kind of things that are being captured by our corners measures. And now word prediction, the task of word prediction, of course, has links not just with word frequency, but with distributional information and forms the basis for language models and is how they are trained. So this, again, follows from the distributional hypothesis, which says that meaning is use in context. And so in that vein, large language models have been shown to have remarkable similarities to humans in various aspects of representation and behavior. And they're able to learn that all from text, which is really remarkable and rightly so. But relatively less attention has been paid to differences between LLMs and human cognition, even though those differences are just as cognitively interesting. And if there are differences between them, as some studies would suggest, then it suggests that there are aspects of human cognition that are not encoded in text and can't quite be learned from text, either because of pragmatic constraints in the way we communicate or because humans also rely on multimodal information that isn't encoded in text. And so the word prediction task allows us to investigate this in more depth. Particularly because word prediction is a task on which language models are trained. So it would be interesting to look at whether there are differences in the task of word prediction. And so here we can ask, to what extent does LLM word prediction align with how humans predict words in context, or are there systematic differences between them? And if there are, can they be captured by our cornice measures? And so what we did is we looked at the responses that people gave on our word prediction task. We looked at their predictability according to language models, so the predictability of each response in each sentence. And then we compared that with the proportions of responses that humans gave us. And what we see here is that there is a correspondence between the language model predictability and the human response probability, so the language model predictability according to BERT. But there are also deviations in the humans from what BERT predicted. And what we found was that those deviations could, in part, be explained by our cornice measures. So we found that responses that were more core in strength and AOA were more likely to be given over and above their predictability according to language models. Interestingly, we found that responses that were more core in frequency were less likely to be given after accounting for all those other factors, which to me really reflects bias against frequency once you take into account all those other things. So in summary, then word frequency-based core words were more useful in this word prediction task. They were easier to guess, but that was mainly, as far as we can ascertain, because of their predictability distributions, because of their high predictability. But what we found is that performance in this word prediction task depended on more than just predictability alone. So the in-strength and AOA target words were better guessed for reasons that go beyond their predictability, and responses that were higher in terms of in-strength and AOA cornice were also given more often than expected compared to the language model predictability. And so this might all suggest that humans differ from language models in how they predict words in context in important ways, and that they may rely on more than just distributional information alone. So I'm going to switch tack now and talk about text and kind of talk about reading comprehension. And so this goes back to one of the key questions about core vocabulary. So what are the most useful words for communication? And in many areas, particularly in the area of applied linguistics, there's often an assumption that high-frequency words are the most useful for communication because they provide the greatest text coverage. So typical findings in this literature include things like 95 to 98% of coverage is needed to gain adequate comprehension. And then how many of the most frequent words are needed to achieve that level of coverage? Around 6,000 to 9,000 of the most frequent words. So high frequency words are often assumed to be the most useful words for communication. But then the relationship between text coverage and comprehension may not be straightforward. And this becomes apparent when we look at models of reading comprehension, again, from the psychology literature. So, for example, Kinch's construction integration model says that comprehension is a process of passing a text into propositional representations, building those propositions into a network, and integrating that with world knowledge. So now what matters is not the coverage of each individual word, but the role that it plays in this kind of network of propositions. And more generally, it's widely accepted that comprehension is a process of constructing mental representations of the situation underlying the text, the content underlying the text, rather than the verbatim or the verbal content of the text itself. And so from this perspective, what matters, again, is not the coverage of each word, but how the words in the text contribute to the mental representations that are being built up by the speaker. So centrally, this is about mental representations. And so coverage may not be straightforwardly related to comprehension. And in particular, what I'm going to say is that some words may provide more information than others. Well, what do I mean by information? Well, information theory tells us that we can think about communication as the transfer of information from a source to a recipient. So during communication, a speaker is aiming to convey a certain idea or meaning to a listener, and the reduction in uncertainty in the listener about what the speaker means is what constitutes information. So we can measure communication as information. And when it comes to text, well, text also aim to convey a certain idea or message from a speaker to a listener. And some words are probably going to provide more information about the underlying ideas and the underlying content of that text compared to others, which are less useful. So the question now of what words are most useful for communication becomes what kind of words provide the most information in texts. So we can come back to our core vocabulary measures again. We've already talked about word frequency, so this idea that high frequency words might be those that are most useful for communication. But then again, frequency is just one measure of distributional importance, right? So it makes sense to also think about how else we can measure coreness that is consistent with this idea of distributional importance. And so a new measure that we're introducing in this study is based on co-occurrence. So we're calling this co-occurrence centrality, and the idea is to kind of capture the words that co-occur the most often with other words in text. But then again, drawing on this idea, this insight that comprehension involves access to and construction of mental representations, it also makes sense to think of words that are core in this sense, that are core semantically, that are rich in semantic content, and that are central to people's mental representations of word meaning. So these measures that I talked about, AOA and in strength, they can be thought of primarily as semantic measures. So it's possible that these kind of words may contribute more strongly to the mental representations that people build up from text and may encode more meanings about the actual world that people are communicating about. And so the question, again, now becomes which words from which type of core vocabulary provide the most information in texts? And when it comes to sets of words, there's a question of how many words should be in that set. So how many words should be in the vocabulary? And there's a trade-off here, right? Because the more words there are in the core vocabulary, of course, the more information you're going to get. But then we kind of think of the principle of core vocabulary that suggests that it should be smaller rather than larger. It should be easier for speakers to learn and use. So another way of saying this is that informativeness trades off with simplicity. And there's two ways that we can formulate that trade-off. So in terms of vocabulary size, again, larger vocabulary is going to provide more information for the amount of, a large vocabulary is going to provide more information about the meanings of the words. But then again, the idea of core vocabulary suggests that it should be a smaller core vocabulary rather than a larger core vocabulary, and it should ideally be a relatively small number of words that are relatively important to the language. And also in terms of coverage. So a higher coverage is going to enable more accurate comprehension, is going to provide more information. But then if you could understand less of a text and still get by with the same amount of information, if you could get the same amount of information from a lower amount of coverage, that would also be more efficient. So we're measuring the trade-offs between informativeness and simplicity in terms of vocabulary size and coverage. And so core vocabulary that is communicatively useful should be communicatively efficient in terms of optimally trading off these two competing factors of informativeness and simplicity. And so the question again becomes, which core vocabulary is most communicatively useful in terms of supporting the most efficient communication? So which core vocabulary provides the most information, more information for vocabulary size, and which core vocabulary provides more information for coverage? And so we ran an experiment where we got participants to play a game where they were guessing, they were reading extracts of Wikipedia articles, and we asked them to guess what they thought the title or the topic of the article was. And so we gave them texts that looked like this, and we showed the core words in the text. So the core words from one of those core vocabularies in strength, AOA, WF, and CC. And we showed these core words incrementally. So we started off with the words from the top 50 words in the core vocabulary, the top 100, 200, 300, 500, so on, getting people to make a guess each time until they either got the topic or again, they ran out of guesses. So the correct answer there is intelligence. And so the articles were taken from the Wikipedia articles from the Wikipedia Vital articles, which is a collection of articles that are considered to be the most important Wikipedia articles. They come from a broad range of categories, so like people, science, everyday life. And for what we did for each article is we took the introductory paragraphs of each article, so the ones that kind of generally provide the most general information about each topic. And then we also drew the answer choices. We had 12 answer choices for each article. We drew those answer choices from the other articles. So we always had one correct option, one option that was in the same subcategory, the same subcategory, 3 options in the same category, but a different subcategory, and 7 from different categories across the vital articles. And the different core vocabularies, again, as you might expect, they also vary in the amount of text coverage at each vocabulary size. And so as you might expect, the distributional ones, the ones that are based on distributional information, they provide higher coverage compared to the other two. And so looking at overall accuracy, the conditions didn't differ much. So only the AOA condition was lower than the others here. But then overall accuracy is not what we're interested in. We're interested in the trade-offs between accuracy and like vocabulary size and coverage. So if we look at accuracy as a function of each increment, each step in the trial that represented the size of the core vocabulary that we were showing at that point. And here what we're looking at is a survival analysis looking at accurate identification over those increments. What we found is that there were differences in terms of in-strength core words providing more information at smaller vocabulary sizes and allowing more accurate identification of trials at earlier vocabulary sizes compared to the other conditions. So again, we can look at accuracy and coverage. So the analysis I'm showing here is what was the level of coverage that the words from core vocabulary provided in the text at the point at which it was correctly guessed. And so what we see here is that the words from the AOA and in-strength core vocabularies, they allowed for accurate identification at much smaller amounts of coverage. That is, you needed a smaller amount of text coverage using those type of words compared to the other 2 types of core vocabularies, which suggests that it is more communicatively efficient. Now, so far, we've only looked at accuracy, but then animation's not working there. If you remember, we motivated all of this from an information theory approach. So remember that our setup included this kind of deliberate design of answer choices that were kind of, again, taken from the same subcategory, the same category in different categories to the correct article. And they kind of reflect increasing distance from the correct answer, increasing wrongness in this kind of hierarchical fashion. And so we also thought, well, can we compute a measure here of informativeness over these distributions of answer choices that is much closer to the kind of information theoretic formulation that we started out with? And so drawing on this framework from work that looks at semantic category systems, we have a target meaning that is being conveyed using a given word, which results in a listener distribution in the listener over the possible meanings that that word could refer to. And then in the framework, we can compute information loss here for that target meaning using the KL divergence between the speaker and the listener distributions for that target meaning. And so thinking about how we could apply that to our setup, what we have is a given topic, a given Wikipedia article that is being conveyed using the words from a given core vocabulary of a given vocabulary size and coverage. That results in a distribution across participants of the types of answer choices that they chose. And then we can compute that. We can use that to compute the information loss. And if we do that, maybe we can look at how each core vocabulary system trades off informativeness with complexity as vocabulary size increases and as coverage increases in kind of the same ways that I talked about before. And when we look at that, we saw that the results align very much with those that we found for accuracy. So it is quite interesting here to see that all four core vocabulary systems actually do exhibit trade-off curves that look something like an optimal trade-off curve. But what we found is that there does seem to be a difference in terms of which conditions are more optimal. And so the in-strength and CC core vocabularies look like they exhibit trade-off curves between vocabulary size and informativeness that look more optimal in that regard compared to the other two. And we can do the same thing again with coverage. So again, looking at the trade-offs between communicative cost and coverage, the AOA and in-strength core vocabularies looks like they achieve more optimal trade-offs compared to the other two core vocabularies, consistent with the accuracy analyses. So far what we've found is that in-strength and AOA core words provided more information than WF and CC. In-strength core words provided more information for vocabulary size, and AOA and in-strength core words provided more information for coverage. Now, just quickly looking at study 4, so we did the same kind of study with the same questions, but using narrative texts instead of these expository factual texts. And so again, we got people to read short stories that looked like this with only certain words from each of the core vocabularies revealed in text. This time we manipulated the text between subjects rather than using this incremental design. And then after participants read those stories, we tested them on their comprehension. And so again, we looking at the coverage, we had 30 text stimuli from 2 text types. So the exam stories were taken from English exams for secondary students. They're kind of a more formal, structured style of narrative. The Reddit stories were taken from Reddit posts, and they're kind of more informal and naturalistic style stories. And again, as you might expect, the WF and CC core vocabularies, they generally provided higher text coverage compared to AOA and in-strength. We tested participants on comprehension by first getting them to summarize the gist of the story in a few sentences. And we compared those gist responses to the full story texts using similarity, using BERT embeddings. And then we got them to answer a series of comprehension questions about key details about the story, like key events, cause and effects, people's motivations and feelings, and so on. So the results, just looking at gist, again, the question is which core vocabulary provides more information about gist for vocabulary size? Kind of rather comfortingly, larger vocabulary sizes led to greater gist accuracy, which is sensible, which is good, nice to see. But again, there are differences between our different types of core vocabulary. So the in-strength and WF core vocabularies consistently led to greater accuracy compared to the other two. Looking at coverage. So again, the question is which core vocabulary provides more information about gist for the amount of coverage. And so again, what is nice to see is that greater coverage leads to greater gist accuracy, which is sensible. But again, in-strength and AOA core vocabularies lead to greater accuracy for the same amount of coverage compared to the other two. So these effects are smaller, but they are consistent with what we found in the last study. And the results for comprehension questions are quite similar as well, but I'm not going to go into that now. So the conclusions here are that measures of distributional importance are, such as high frequency words, have been argued to be a good way of identifying the most useful words for communication, but coverage is not all there is to comprehension. And accordingly, what we found is that core words based on semantic centrality fared at least as well as distributional based ones in terms of how much information they provide. And this is applied to a variety of text genres and methods of measuring comprehension. And we argued that this is because comprehension inherently involves the use of mental representations, and that is what definitions of core vocabulary based on distributional characteristics alone miss. It was also interesting to see that we could show kind of that core vocabularies may exhibit these trade-off curves that look like efficient communication for semantic category systems in the world's languages. So now to wrap up, and overall kind of piecing this whole project together with a few coherent thoughts. We have attempted to define measures of core vocabulary that are based on how people learn and represent and process language. We have shown that there are potential interesting differences between LLMs and human cognition, and I think this is a pathway that would be interesting to follow up on with different tasks or behaviors or processes. We've brought into question this idea that high frequency words are necessarily those that are most useful for communication. Of course, the big question is, have we found the core words? I don't think so. The more I've kind of done this project and thought about it, it makes less sense to say that there is a single kind of core vocabulary that is for everything that humans do and use language for. And it makes more sense to say that core words that are more or less important in different ways are more or less useful for all of the different kind of things that we do with language. One common theme that we did find, however, sorry, yeah, that's that point. And then one common theme that we did find is that there was a kind of higher utility of these semantic-based core vocabularies. So we consistently found that they did better than expected, whether that was in lexical representation or word prediction or in terms of comprehension. So it might suggest that there's a utility on using these kind of measures to define what makes a word important psychologically. I want to thank my supervisory panel. So I want to thank Andy for all your guidance. You've made me a better thinker and a better writer and a better presenter and a better collaborator. And you've made me think about this PhD journey in a very different way to when I started. Meredith, who has been there since the beginning, since Capstone, which is and is the reason why I'm even here in the first place, and you've just granted me so many opportunities in research and in teaching. To Simon, who's mentored me through so many aspects of my research journey and challenged me conceptually and technically in many ways that I think are still beyond me, but I'm slowly working towards. And I also want to acknowledge Charles, who's in his capacity as my chair, and just having the privilege of working alongside you, like in the lab and in teaching, as well, has been a real privilege. And I want to thank all the people here, all my friends in the hub and from Psych, who have been along with me in this PhD journey. And I want to acknowledge all of you as well. So thank you very much. Thank you for being here and listening to me talk. Thank you.
Class online. We've probably got time for about a few questions. Andrew, you select.
Oh, yeah. John, please go ahead.
Okay, Amber, the really cool.
Thanks.
I just wanted a bit more clarification on how exactly the in-strength measure is defined with respect to the semantic network structure.
Sure. I should have gone into that, but I didn't. Didn't have the time.
Does in-strength kind of mean like an in-degree situation?
Yeah, it's talking about strength centrality there. Well, in degree and then weighted edges. Yeah. So the sum over all weighted edges. And if you have a directed network, so one with incoming and outgoing edges for everyone else, then you're looking at the incoming links to a node rather than the outgoing ones. So weighted incoming edges.
I may also ask a follow-up. Does that imply there's like that the networks you looked into were directed in the sense that these associations were asymmetric between these?
Yes. Yeah, they're directed because the word association task involves a cue and a response. So the direction of the nodes is going from the cue to the response. That's where the incoming edge goes. You can't do it the other way because you control how many times the cue was presented. So that wouldn't be useful. Yeah. But there are other ways, like you could think of closeness centrality in between. The centrality is one. We did look at these kind of things. Ultimately, we decided with this. But those are like other potential interesting directions I would take this. Yeah.
Thank you.
Thanks. Yeah, Dan.
I know you settled on the idea that there might not, be this set of core words, but I was just thinking about like knowing that people have quite a different vocabulary in written text versus spoken text. Would you imagine the idea of a core word to be different between the two? And might the sort of spoken core words be a bit more representative because we tend to speak more than write? Or what do you?
That's a good question.
That's I don't know. In my head. I think
Yeah. No, it's a really good question. I actually imagine it could go either way. I still think there has to be kind of it's ultimately the same language, whatever the modality is. There has to be something that's common to both of those things, and that might be something you define as core. By definition, you might count the core as the things that are common to speaking and writing. So it is hard to say. Yeah, but I suspect that we're after something kind of blatantly central to both of those things.
Your narratives are much more speechy than your expository text, for example.
They would
so
be.
There's a kind of formality to the writing of an expository text
Yeah.
that is different from those sort of Reddit posts.
Oh,
and
yeah,
things that
definitely.
You use. But I think it's a really interesting
Right.
question about.
Yeah.
I mean, it's very much sort of it's so much easier to research language using written words than spoken
Yeah,
words.
it is definitely.
There's something about speech that's obviously fundamental to humans.
Yeah.
That written words is parasitic of. That it does obscure things that looks interesting.
Yeah, it's true.
I mean,
Yeah, it is.
but when you ask about it, so you say there's the utility of these words at the end. It does make me wonder what it's coming down to, and it makes me think of things like valence and arousal and what it is about the in-strength words.
Yeah, or possibly multimodal information, perceptual, affective. Yeah. Ted, go ahead.
What do you think, like all this results have implication on evolution of lexicon? Yeah, I
That's-
just wanted to hear.
That's a good question. I don't know if I can.
Yeah, in terms of
can
the
answer that.
core vocabulary and evolution of lexicon.
Yeah, that's a good question. I guess it's not a perspective that we've really looked into here because we haven't looked, diachronically. We haven't looked across time or in terms of across the world's languages. I would say, I guess I'd posit there's a link. Like if there are words that are core psycholinguistically in terms of the things that we do with language, that you can imagine how that scales up to evolutionary timescales, right? That possibly, that would persist over how a language evolves over time. But ultimately, I haven't examined that, right? It's just one of those different ways of defining a core vocabulary. Like, do you define it in terms of language evolution, or do you define it historically, or do you define it in terms of these terms? And I've chosen to define it in these terms.
What that was like, you imagine there's a hunter-gatherer group,
Yeah.
Inventing language, and then only there's just limited number of very few words, and what percentage would be the highest for maybe frequency words or in-strength words, and it's just kind of interesting.
Possibly, yeah, I think so. It comes down to the same definitions, like what are the most useful words for communication, the essential ones for communication. Like if you think about that kind of hunter-gatherer situation, yeah, the words that are most salient in the environment, I suppose. Yeah, there's probably links there. Yeah.
So I hate to cut this off,
No,
but I have to, thank Andrew one more
Thank you so
time.
much.